Okay, so for this FRQ problem, calculator is allowed. So I'm curious where I would have to use a calculator, but I guess we'll find out. So g prime of 3 is f prime of x squared minus x times x squared minus x prime, which is f prime of x squared minus x times 2x minus 1, evaluated at 3, okay, at x equals 3. So what happens here is this becomes f prime of 9 minus 3, which is 6, times 5. So f prime of 6 is equivalent to 4, which I got from here. And that's 4 times 5, which is 20. So that would be my answer for part A. Part B, it is known that g double prime of 0 equals negative 1. So what is f double prime of 0? Interesting. Okay, so let's see here. Well, so we want to get to the second derivative, right? So we know that g prime of x is equal to 2x minus 1 times f prime of x squared minus x, right? So where did I get that? I got that from right here. And then now what they want us to do is they want us to go ahead and find g double prime of x, which would be a product rule, right? So first times the derivative of the second, but check this out, that this is going to be f double prime of x squared minus x times 2x minus 1, because it's a chain rule. It's another chain rule. Plus the second times the derivative of the first, which would just be 2. Okay. And then, so now what they want us to do, so it is known that g double prime of 0 equals, so what they want us to figure out is what is f double prime of 0? In other words, if all of these terms get replaced with x equals 0, then this would be g double prime of 0 equals negative 1 f double prime of 0 times negative 1 plus f prime of 0 times 2. And so if I do some replacement here with g double prime of 0 equals negative 1, so this is negative 1 equals f double prime of 0 plus 2 f prime of 0. I go back to my chart, my f prime of 0 is 2. So this becomes negative 1 equals f double prime of 0 plus 4. And so f double prime of 0 equals negative 5. Part C, is there a value C? Okay, so this is an, what do you call it? This is an intermediate value theorem problem. So is there a value C for 0 to C to 3? So in other words, x going, so this is talking about the x value such that, so this is that thing where we're going, okay, what is g of 0? What is g of 3? So g of 0 is f of 0 minus 0, which is f of 0, which is equal to 4. And then g of 3 is f of 3 squared minus 3, which is f of 6, and that's equal to 7. There we go. So now we just write out our IVT. But the answer would be yes, there is a g of c that equals 5 by the intermediate value theorem. And if you remember, the intermediate value theorem was a thing where, you know, from 0 to 3, and then we know that this is 4, we know that this is 7. So we know that there's some sort of, you know, action happening. Okay, and then for part D, let h be the function with derivative given by h prime equals that. At what value of x, in the interval -3 to 0, does the instantaneous rate change? So when does h prime equal the, okay, so average rate of change. So f of b minus f of a over b minus a. F of 0 minus f of -3 over 0 minus -3. So f of 0 is 4 plus 5, because it's a minus -5, over 3, which is 9 over 3, which is 3. Okay, so there it is. So when does 4e to the cos x equal 3? And we want that x to be between -3 to 0. So this is where our calculator comes into play. But we know we can take the ln of both sides. So cos x equals ln of 3 over 4. And then x equals the inverse cos of ln of 3/4. So if I grab my grapher, inverse cos ln 3/4, then I would probably get 1.86. So what I got for my answer is x equals 1.86 radians, right? So let me go ahead and okay. So what this is telling me then is that 1.86 radians, so, like, for example, pi over 2 is about 1.57. So if I just say, like, 2 pi over 3, for instance, right, 209. So I know that 1.86 radians is maybe around here somewhere. So the question is asking us, in the interval from -3 to 0, and I know that cosine would have the same value here. And I know that 0 to -3, this is a little trickier than I wanted it to be, but I know that from 0 to -3, well, I know that this is -3. Yeah, so this would be -3.14, and this is 0. And so this right here, this 1.86. So if I do 2 pi, or you know what? I'll just call it that. So x equals -1.86 radians. Okay, so there's the answer for part D. That's that's a bad explanation. But just with the understanding that if I were to take the cosine of a value, whether I was here or here, it would be the same x value, which would be negative. And with them desiring the answer to be between -3 and 0, I would go the opposite way and say -1.86. Okay? All right. Hopefully these are a little more fun. Okay, so show that. So we're just going to derive each one of these. So first term is like that. Minus 24 equals 0. And then show that. So it's just a lot of steps, right? But I can show, let's see here, that I know that this is 6. Equals 24. There we go. Okay, and so that is what I'm showing. Writing an equation for the line tangent to the curve at the point -1, 2. So I just need a slope. Equals what? So I'm going to plug that into the dy dx. So slope equals 4 over 2y plus 1 quantity squared. 4 over -3 quantity squared. How did I get that? I plugged in -2 into y. And so that's 4/9. 4/9. And so y plus 2 equals 4/9 times x plus 1. There's an equation of a line tangent. Now they want us to find the second derivative. So I can rewrite dy dx as 4 times 2y plus 1 quantity to the negative second power. And then I can go ahead and take the derivative of that. So d squared y dx squared is equal to 4 times negative 2 times 2y plus 1 to the negative 3 times 2 dy dx, which can once again be replaced with 4 over 2y plus 1 quantity squared. So there is an equation for my d squared y dx squared. And then now I'm just going to plug in negative 2 into that value. So d squared y over dx squared evaluated at y equals negative 2. And that would give me, so 4, negative 2, and I don't see any addition, so I'm okay with doing it. So let's multiply all of that. So 4, negative 8, negative 16, negative 64, all over 2 times negative 2 plus 1 to the power of 5. There we go. And then negative 4 plus 1 is negative 3. So negative 3 to the power of 5, 3, 9, 27, 81, 243. So that's negative 243 on the bottom. That's negative 64 on the top. And so there is my answer. And I don't think that thing simplifies from what I can tell. Okay, find the value of y inverse. So dead giveaway, right? 1 over y prime of y inverse of 0. Okay, now this looks a little, so you know what, let's just, y inverse of 0. Y inverse, so yeah, I mean, so that's basically like saying f, yeah, y inverse is basically saying f inverse, yeah, so it's just f inverse of 0. Okay, so first, the y inverse of 0 would be 1/6. So that's equal to 1 over y prime of 1 over 6. Okay, now, interesting. So, So keep in mind, this is an x value of 1/6. But if I look at my y prime equation, it's, back in part A, my y prime equation is 4 over 2y plus 1 quantity squared. So the x equals 1/6 is not particularly helpful. However, when I go back to my original equation, which is 2y plus 1 quantity cubed minus 24 times x. So there's the x times 1/6, that would equal to negative 3. And this becomes negative 4. I move that over, that becomes 1. So 2y plus 1 to the third equals 1. And from there, I know that 2y plus 1 equals 1. And so I know that y is equal to 0. And so if that's equal to 0, this would give me, there we go, 4 over 1. So the answer would be 4 for part D. Okay, the last part. Let g be the function defined by this. Find g prime of negative 1. So g prime is a quotient rule problem, which is the second times the derivative of the first, f prime of x squared times 2x, because of chain rule, minus the first times the derivative of the second, all over the second squared, e to the 2x. And so g prime of negative 1 is equivalent to e to the negative 1 times f prime of 1 times negative 2 minus f of 1 times e to the negative 1 all over e to the negative 2. And those guys all drop down. So this would become e to the negative. No, it wouldn't. So I'll just leave it like that for now. And then I know that my f prime of 1 is going to be 4/3. I know that my f of 1 is going to be 2/3. I can factor out my e to the negative 1. Let's just do that. And that's going to be negative 8/3 minus 2/3, which is negative 10/3, all over e to the negative second. So if I do a little switcheroo here, the e squared comes on top. So negative 10/3 e squared all over e, which gives me an answer of negative 10/3 e. And I think that would be my answer. Okay, so negative 10 over 3 e would be answer to the g prime of negative 1. Okay, so h prime of this guy would be the derivative times the derivative of the inside, which has two chain rules in there. And then h prime of positive 1 being f prime of f of negative 2 times f prime of negative 2 times negative 2. There we go. So this becomes f prime of f of negative 2, which is negative 3, times f prime of negative 2, which is 1/3, times negative 2, which equals f prime of negative 3 would be negative 1, times 1/3, times negative 2, 2/3. There's my answer. Let k be the, okay, find k prime. So first times derivative of the second plus second times derivative of the first. So first times derivative of the second, 1 over square root 1 minus x over 2 squared times 1/2 because of the chain rule, plus the second times the derivative of the first, which is f prime of x. So now what we got to do is just plug in k prime of negative 1. So f of negative 1 times 1 over the square root of 1 minus 1/4 times 1/2 plus arc sine negative 1/2 times f prime of negative 1. So I know that f of negative 1 is equal to negative 2. I know that f prime of negative 1 is equal to 6/5. And then I know that arc sine of 1/2. So in other words, when is the y equal to 1/2? It's going to be here and here. So what is that? 7 pi over 6 and 11 pi over 6. So negative 2, okay, so that's going to become negative 1. Oh boy. So that's negative 1 over square root of, square root of 3/4. So which is negative 2 over root 3 plus 6/5 times negative pi over 6. Okay. And then if you go ahead and work that out, that'll take you to an answer. All right.